All right, in this video, we're going to talk about the first part of section 4.5, which is differentiating logarithmic functions. And the first type of logarithmic function that we're going to differentiate is going to be the natural logarithmic function. So if we have a function y equals ln of u, where that's representative of log base e of u, y prime is going to be 1 over u times u prime, or you can write that as u prime over u. It's going to be a little bit different for the formula. If we have a log base that is not e, this is the easiest case for us to deal with. So we're going to deal with it first. So let's look at number 1. Y is equal to ln of x to the 8th. Now we can either use the chain rule here, or we can use a log property, and I prefer to use a log property to help us simplify this first. That this is 8 times ln of x. So y prime is going to be 8 times, and then 1 over x is the basic form of this. So this is 8 over x. If you wanted instead to say that y prime was going to be u was x to the 8th, so that could go down there, and u prime was 8x to the 7th, and then you would cancel and you would get 8 over x. You're going to get the same answer either way. So take your pick how you want to deal with that. Use your log property and make it simpler, and then differentiate, or differentiate with the more complicated function and use the chain rule. Let's go ahead and look at number 5. And y is equal to ln of the 4th root of 3x minus 5. Now this is definitely one where I want to pull that out to start out with. And I want to make my u 3x minus 5 and my u prime equal to 3. So y prime is 1/4 of, and there's 3x minus 5 down there and up here. So this is going to be y prime is 3/4 times 1 over 3x minus 5. Maybe write that as this if you prefer. Maybe even get rid of those parentheses if you want. All right. Let's look at number 7 now. Number 7 is a little different, and we can't use that log property that we've been using to simplify, because now our u is ln of x, and our u prime is 1 over x. We have a u to the n situation here. So y prime is going to be a 4 times u to the 3rd times u prime. So y prime is 4 times ln of x to the 3rd times 1 over x. So this is 4 times ln of x to the 3rd over x. It's different than our first one, where we had ln of x raised to the 8th, and the x to the 8th was inside the ln. Now this is the entire ln of x that's raised to the 4th power here. Let's go ahead and let's look at number 9 now. Number 9 says f of x is equal to 2x times ln of x. So my u will be 2x and my v will be ln of x, making my u prime 2 and my v prime 1 over x. So f prime of x is going to be u prime v plus v prime u. How I remember that? u prime v to ln of x plus v prime u is 2x over x, and that will cancel, leaving me with 2 ln of x plus 2. That's the same thing as 2 plus 2 ln of x if you ended up with it that way, because you did uv prime plus vu prime. Let's go ahead and look at number 11. Number 11 says y is equal to ln of x root x to the 6th minus 2. Now again, I'm going to use some log properties to help me. It means that y is equal to ln of x plus ln of root x to the 6th minus 2. And that 1/2 will come down as a coefficient. So y prime is 1 over x plus 1/2 of x to the 6th minus 2 is in the denominator. The derivative of that, 6x to the 5th, is in the numerator. And so 2 goes into 6 3 times. Y prime is 1 over x plus 3x to the 5th over x to the 6th minus 2. To me, that's a legitimate answer. If you want to make this have a common denominator, then that's going to be x to the 6th minus 2 plus 3x to the 6th over x times x to the 6th minus 2 is going to be 3 plus 1 is 4x to the 6th minus 2 over x times x to the 6th minus 2. You can factor that 2 out. But that's not going to get you anywhere if you do that. So let's look at number 15. 15 says y equals natural log of the cube root of x minus 1 over x plus 1. So y is 1/3 natural log of x plus x minus 1 over x plus 1. Y equals 1/3 of the natural log of x minus 1 minus the natural log of x plus 1 is y is equal to 1/3 ln of x minus 1 minus 1/3 ln x plus 1. So y prime is going to be 1/3 times 1 over x minus 1 minus 1/3 times 1 over x plus 1, or y prime is 1/3 1 over x minus 1 minus 1 over x plus 1. If we want to make a common denominator there, we have x plus 1 minus x minus 1 over x minus 1 x plus 1 will give us y prime is 1/3 of x plus 1 minus x plus 1 over x minus 1 x plus 1 is x minus x is 0, so that's 2. 2/3 times 1 over x squared minus 1, like that. Let's look at number 19. Says that g of x is equal to e to the negative x times ln of x. So we have u is equal to e to the negative x and v is equal to ln of x. U prime is a negative e to the negative x and v prime is equal to 1 over x. If this is u times v, I say g prime is u prime v plus v prime u. So g prime is negative e to the negative x, ln of x plus 1 over x e to the negative x. Your book is going to factor out an e to the negative x or a negative e to the negative x, probably an e to the negative x, and make this 1 over x minus 1, something like that. So there you have it. And then we have number 21. And it says g of x is equal to ln of e to the x plus e to the negative x over 2, which I know is hyperbolic cosine, and the so I'm going to do it down here that way and say that that means that g prime of x is equal to over that, and the derivative of that, which should be that, and let's see what that's equivalent to up here, right? So before we get started, let's use the rule about a quotient inside of a log like that. And then g prime is going to be this. And then the derivative of that is going to be that. And then derivative here is nothing. And I can multiply top and bottom here by a half to get what I was saying before. This is fine to say that it's e to the x minus e to the negative x over e to the x plus e to the negative x. But that's the same thing as me saying that half of this up here is hyperbolic sine, half of this down here is hyperbolic cosine, and sine over cosine is tangent, but this is hyperbolic. So, however your book gives the answer, whether it gives e to the x minus e to the negative x over e to the x plus e to the negative x, or they might multiply by another form of it that they could give. If they multiply by e to the x top and bottom, it's e to the 2x minus 1 over e to the 2x plus 1, something like that, would also be an equivalent answer. All right, that's it for this video, and we'll come back next time and we'll talk about some problems where we are differentiating logs that have other bases other than e. So see you for the video.